So we're now going to look at 2.2. Now 2.1, there really wasn't much to it. When we talked about 2.1, that was just finding your intercepts and completing ordered pairs. Most of you should be pretty familiar with how to do that. 2.2, though, is all about the slope. And I picked some questions that I think we need to review, just so you do well on the homework. So let's look at question 3. Now, question 3, they give you a graph, and they want you to find the slope. Okay, so they want you to find the slope here. Here's what your line looks like. They want you to find the slope. Now, what do we know about the slope? Well, the slope is also referred to as m, and the slope is the rise over the run. Now, when I look at this line right here, do you think this line is going to have a positive slope or a negative slope? Which one? If I look at this green line I've got here on the graph, you think it's going to have a positive slope or a negative slope? It's going to have negative slope, right? Why is it going to have a negative slope? Because it is going down from left to right, isn't it? Now the slope is a ratio, so that's a fraction of the rise over the run. So let's figure out our rise and our run here. Where I start is going to be right about here and here, right? -4 and -4. So how do I get from this point, right here on the graph, to this point? And you can use any 2 points, but these are going to be our easiest to get to. So if I go from this point to this point, what am I going to have to do? Well, I'm going to go down and then over. And it looks like I'm going to have to go down 4, right? And then I'm going to have to go what? Forward 4 units. So when I look at my slope, again, slope is the rise over the run. It looks like to get from this point to this point, I'm going to have to go down 4 and over 4, and that reduces down to make it then a what? 1. And it's going to be a -1. Why is it going to be a -1? Because when you look at this, you are doing what? You are going down from left to right. Is everyone all right with that? So negative slope goes down from left to right. Positive slope would go up. So positive slope would look like that. What about a zero slope? Zero slope is going to be horizontal, and an undefined slope would be vertical. So just kind of keep that in mind. Question 4. And I picked this one because this one we need to find the slope, which is what we're going to be doing today, an extension of this, and we want to graph this line. And this one also has a fraction, and that's kind of why I picked this one also. So first off, if I want to graph this line, I need to find the slope. Now, whenever we have an equation, we want it to look like this. So it needs to look like y equals mx plus b. And this m, well, that is going to be the slope. And the b, well, that is going to be your y-intercept. And that's 0, comma b. And this is what's called slope-intercept form. And we're going to learn more about this today. This is called slope-intercept form. There are 2 ways we can write line equations. There is slope-intercept form, and there is standard form. We're going to look at standard form today, as well as slope-intercept. So, we want to go ahead and make this look like this. Well, how do we do that? We need to solve it for y, because y needs to be by itself. So we're going to divide everything by the -5 there. Okay, and once we divide everything by the -5, that reduces down and that gives you a y. Negative and negative makes it a positive 4/5 x. Negative and negative here make it now a positive 12/5. So now we have it. It has been solved for y, and now we need to graph it. So our slope, m, is 4/5, and our y-intercept is 0,12/5. Now, how do we graph 12/5? Well, what's 12/5 as a decimal? Okay, well, 12/5 as a decimal, and that would come out to be exactly, what is it, 2.6, I believe? So, or 2.4, sorry about that. 12 divided by 5, that comes out to be 2.4. So when I go to graph this, 12/5 is going to be in between what? In between 2 and 3, right in the middle. They don't have to be perfect graphs. Whenever you graph a fraction, you just figure out what the decimal equivalent is, and that's going to kind of give you an idea of where to begin. So now, what do we need to do? We need to graph this. We have what we need. Remember, how can we graph a line? 2 points, point and a slope, or an equation, right? So we already have the equation. Now we have the slope, we have our y-intercept, so we can graph it. Sure. Sure, yeah, no problem. Okay, so this is what we've got. And what about that 12/5? All right, well, 12/5, that's 2.4, right? So that's going to be in between 2 and 3. And we don't have to have a perfect graph. We just have to have it labeled. So that's going to be right about here at 0,12/5. And then what about my slope? Okay, the slope, m, is 4/5. So rise over run. We go up 4, and we go over 4. Okay, so let's now go ahead and figure this from here. So where do we start? We start right here. Okay, this is where we start. And we're going to go up 4. So 1, 2, 3, 4, right? 1, 2, 3, and about 4. And then we have to go over 5. So 1, 2, 3, 4, 5 units over. So up about 4, over about 5. That makes that new dot right there. And you can label it if you want, but you really don't need to. All we have to do is to make sure that we graph it and it looks right. And then we're going to connect these together. That means that you graph it whenever we connect them together. That's graphing of the line. And we can check and make sure that it kind of looks right, because what do we know about the slope? We know the slope is 4/5. Okay, 4/5 is positive, so that means if we did it correctly, this graph should be going up from left to right. And it is. So we now have our graph done. We have our slope, which is here, which is that positive 4/5. We plotted our 2 dots. Y-intercept was right here, and that's at about 0,2.5. And then we went up 4 and we went over 5. So that makes the next dot there. Connecting them together, and we get then our line. And I picked that one because I think that was the most challenging one of those particular types. Okay, and that was question 4. We'll look at question 7, then we'll do 12, and then we'll move on to the next section. And if you have more questions, we can go through more questions. We have plenty of time to work these out. Now, what are the directions on 7? Okay, 7 says, are these lines parallel, perpendicular, or neither? So these are going to be parallel, perpendicular or neither here. And this is out of 2.2. Okay, so we're at 2, here. It says, are these lines parallel, perpendicular, or neither? Well, how do we know if they are parallel, perpendicular, or neither? Well, if we want to see what they are and how they relate to each other, we have to come up with our slope, right? And we just found our slope a minute ago on question 4 by solving for y. And so that's what we're going to do here. We're going to take these and we're going to solve them for y. We need to make sure we reduce them down, and then we're going to compare the numbers in front of the x. That's your slope. So let's begin by moving that 12x over. And we'll do each side independently. So now we have 4y equals a minus 12x plus 16. And then we'll divide by our 4. And now we've got y equals a negative 12 divided by 4. That's a negative 3x. And 16 divided by 4, that makes it a positive 4. That negative 3, well, that is your slope. So there's that one. Now, we're then going to take the other one, and we're going to repeat the process. And that is 2y equals now a negative 6x plus 9. Okay, we'll divide by our 2. And that leaves you with y equals negative 6 divided by 2. That makes it a negative 3x. And then we have our 9 halves there. So my slope again would be a negative 3, wouldn't it? Right? So both of these have the same slope. So what are they? Can someone tell me? Are they parallel, perpendicular, or neither? Which one? The slopes are the same. Anyone remember? They're going to be parallel, right? Because what is the definition of parallel lines? Parallel lines have the same slope. These both have a negative 3 for the slope, so these would be parallel. Is everyone okay with that? Solve each one for y, and then we compare them. Now, parallel means they are the same. Perpendicular means they are reciprocal, so they're flipped over and opposite in signs. And neither means they are completely different. So on question 7, what I'm looking for there is parallel. And then I wanted to do one more from this section. And question 12, we need to find the slope. So we're going to be finding the slope here when you're given 2 points. So I tried to pick many of the different kinds. So this one, you want to find the slope. And you're given some points here. You're given minus 3, minus 3. And you're given minus 3, positive 7. Now, what's our formula for the slope? Our formula for the slope is y1 minus y2 over x1 minus x2. Now, why is the y in the top half of this fraction? Well, if we think about our slope is rise over run. When I talk about rising, that's going up and down. So that is the y component. Run is the left and right component. So that's why the y's are on the top, x's are down below. We label them as x1, y1, x2, and y2. We need to watch out for double negatives when we plug these in, if we have any. So what do we have now? We have y1, which is a minus 3, minus y2, which is 7, divided by, we've got down below, minus 3 for the x1, minus a minus 3 for the x2. And we know the double negative here is going to now make this positive. And minus 3 minus 7 that makes it a minus 10. Minus 3 plus 3, that's 0. What about a number divided by 0? Is that 0 or is that undefined? Does anyone remember? Negative 10 divided by 0. Would that be 0 or would that be undefined? Does anyone remember? It's not 0, is it? Right? 0 is in the denominator. So negative 10 divided by 0, that would be what? That would be undefined. And if it's undefined, what kind of line is it? Remember, if it's undefined, that's going to be a vertical line. Vertical lines are undefined. So it's undefined for the slope. You might also say no slope, but I usually say undefined. And the line that it's going to be when you graph it is vertical. If it was 0, what would it be? Okay, if it was 0, it would be a horizontal line. And the 0 would be on the top. So if this was 0 divided by negative 10, it would be 0. But in this case, the 0 is down below in the denominator, so that makes that then undefined. Did we have any other questions out of 2.2 to look at? Any other questions? Well, if not, then we'll go ahead and move on now, and we'll start 2.3. And 2.3 is all calculational. So we're not going to be graphing in 2.3. We're going to be calculating through. We'll be working with the slope. We'll be finding line equations, and we'll be putting them in both slope-intercept and in what's called standard form. So let's go ahead and begin our lesson today. And let's talk about the two different forms, what they are, and how you write your answer. So we have two different ways of writing our answer. We can write your answer in what is called slope-intercept form. And slope-intercept form is y equals mx plus b. And then we also have standard form. And standard form is ax plus by equals c. And these are capital letters, and so that means a, b, and c are integers. So no fractions, no decimals. So if you've got fractions, you'll have to clear them out. So no fractions or decimals. And also, a must be positive. So a has to be a positive number. So the reason why they're capital letters is because that means they are integers. So whenever you have capital letters like that, that's a key indication in mathematics that those are going to be integers. So no fractions and no decimals. And also in standard form, we always make sure that a is positive. So these are the two ways that we can write our answers. So first off, we're going to learn how to convert these. So how to convert them from either slope-intercept to standard or vice versa. So we'll do probably 3 or 4 of these, and then we'll look at how to come up with our equations. So the first one I'm going to have you do is I'm going to have you write this in standard form. So this one is not in standard form, and I'm going to have you write it in standard form. So I want you to write this in standard form. Now, why is this one not in standard form? Okay, standard form looks like what? Looks like this. Ax plus by equals c. So the x, the y, and the c. Now, why is it not in standard form? Well, A, B, and C must be integers. So no fractions or decimals. So how do we make this one now in standard form? Right? It's not in standard form, but we can make it in standard form by multiplying everything by what? How do we clear the fractions? Does anyone know how we clear those fractions? Multiply this by what? If I want to clear that out, what's my denominator? My denominator is a 7, right? So I've got to multiply all of this by what? 7. So we're going to multiply all of this by 7. And that's going to take care of our fractions, and then we'll see if it's in standard form. So 7 times 4. We multiply it through here. 7 times 4, that makes it a 28x. The 7 and the 7s cancel out. That leaves you with a minus 4. And 7 times 3, that makes that now a 21. Is that in standard form? Yes, it is. So let's talk about why this is in standard form. It has to meet these criteria. It has to look like this. The x, the y, and then on the other side is the equals, and that's your number. So x, and that should be a y there. My mistake. Sorry about that. That should be a y. I wrote down the wrong variable there. But that's your x, that's your y, and that equals. Okay, so x, y, and then it equals. That's right. No fractions or decimals, so that's okay. And the a, the number in front of the x, must be what? Positive. So that is in standard form. Let's do another one. This one will have to move things around a little bit. So I'm going to have you write this one also in standard form. So I want you to have this one written in standard form. Well, what do we need to do? Well, to make it in standard form, we need to make sure that the x's and the y's are on the left-hand side. So I'm going to move that 7x over. Now, I specifically picked this one because it's not quite in standard form yet. It looks like it is, but what do we know about standard form? The a, the number in front of the x, which is here, that number must be positive. Uh-huh. Sure, yep. Right back here. I'll be right back. That will be positive. This out. Okay, so we know that must be positive, and in this case it is not. So how do we fix it so that it's in standard form? Well, if we want to fix it so it's in standard form, we're going to distribute a negative through. And that's going to switch our signs out. And that leaves me then with positive 7x, which is what we want, a minus 2y. Negative and negative makes it a positive 9. And that is now in standard form, right? No fractions, no decimals, and the x is positive. The y can be negative, but the x has to be positive. Now let's do one where we do the opposite, where we go to slope-intercept form. So now we're going to write this one in slope-intercept form. So for slope-intercept form, we want it to look like y equals mx plus b. So we want it to look like this. Okay, so we can have fractions. That's not a problem at all. So we're going to write this one in slope-intercept form. And how about we have 3x minus 8y equals 2. So I want to write this one in slope-intercept form. And you've probably done this one before. I know we did one earlier today. We did the parallel lines a moment ago in 2-2. We want this one in slope-intercept form. So we're going to solve it for y. So we're going to move that 3x over. And now we've got minus 8y equals a minus 3x plus 2. And we'll divide by our negative 8. And always make sure you reduce. You need to reduce this down as far as you can, if possible. Negative over negative makes it a positive 3/8 x. Positive over negative leaves it as a negative 1/4. So that is your answer in slope-intercept form. So what we're going to be looking at next is we're going to be looking at how to write answers now and how to write these in either standard form or slope-intercept form, but you're only given part of it. So you might have a point and a slope, which we'll look at first. You might have 2 points, and you might have a line equation and a point. So I've got a handout that I think is very helpful to students when we work these out. So I'll go ahead and pass out the handout here. And this is a flow chart, and I think it really helps work these out. We're going to go through all 3 of them, because there are 3 of them. And again, you can use this on your exam too, so you don't have to memorize anything. This is going to really help you when you go to work these out. Flowcharts are used a lot in different disciplines. It's like a recipe. When we do these, it's just like cooking. It's like following a recipe. You do this, and then you do this. So the first one that we're going to look at is we're going to be finding the equation of a line when you're given a point and a slope. So the first box tells you what you have. So you need to make sure that you have a point and you have a slope. And then we're going to be using what's known as the point-slope form. Okay, so here's our point-slope form, formula. And then we either write our answer in either standard form or we write our answer in slope-intercept form. We'll do a couple of these. We'll do one in standard form, and then we'll do one in slope-intercept. So I'm going to give you a point and a slope. And we're going to find the equation in, let's do this one in standard form. And so you're going to be given a point, let's say 4, -3, and you'll be given a slope of, how about minus 2/5. Okay, so how do I know I'm going to use this flow chart? Well, to use this first flow chart, we need to make sure that what we have is here. And it says, find the equation of a line given a point and a slope. Well, that's what we've got. You need to make sure you use the correct flow chart, point, and a slope. So follow it just like a recipe. Many different industries use flow charts. You might see them if you take a business course. A lot of times in decision making, there's flow charts as well. So this is what we've got. Now we follow it. And what does it say to use? It says to use the point-slope form. So I'm going to write up the point-slope form. And that is y minus y1 equals m times x minus your x1. And we label our ordered pair, x1 and y1. So we label it x1, y1, and now we fill it in. Watch out for double negatives. So we have y minus a minus 3 equals minus 2/5 times x minus 4. So when we look at this one, we're in 2.3. Just pass up this flow chart. And this is what we're going to be using to help us find the equations of different lines. When we fill in the blanks here, double negative here is going to make this now a what? Positive. And when we distribute through, we have to be careful. Make sure you distribute that negative through as well. And when we distribute the fraction through, we just multiply. So that gives you now y. Double negative makes it a plus 3. That equals a negative 2/5 x. Double negative make it positive, and then we just multiply. Negative 2 times negative 4, that makes it a positive 8. 5 times 1, that makes it a 5. Now, we want this one in standard form. And it already has it listed on your sheet here. Okay, so this is the flow chart, right? When I just copied it, it was easier to copy a landscape than it was a portrait, so that's why it's written like this. Find the equation of the line. We did that. Point the slope. We used our point slope formula. Now, we want it in standard form. Okay, so x and y are on the same side, and can we have any fractions? No. So the first thing we want to do is clear out the fractions. How do we do that? Well, the only denominators that we have are 5s. So we're going to multiply it all by 5. And then we'll distribute through. So that gives me now 5y. 5 times 3, that's 15. The 5's cancel. That leaves you a minus 2x. The 5's cancel, and that leaves you with an 8. And we want to write this in standard form. So I'm going to add my 2x over. That way the x's are on the left with the y's. And move the 15 over so that it's on the right. And now it should be in standard form. And so that is 2x plus 5y equals a negative 7. And that is now in slope, or not slope intercept form, in standard form. Right? This is in standard form, and that's what we wanted. Let's do one more of these, and then we'll look at what happens when we have 2 points. So one more like this. The next one we'll do in slope-intercept form. So we'll write this one in slope-intercept form. Are we finished? All right, yep. I will get that graded for you. Yep, you're welcome. So we're going to write this one now in slope-intercept form. Okay, and just pass this out as well. This was a handout we were using. We're in 2, 3. And we're going to write this in slope-intercept form. And so we're using the first page of this handout. And we're going to write this in slope-intercept form. I'm going to give you a point and a slope. So let's say I give you the point 5, 0. And how about a slope of 10? So I made this one fairly easy. We want to write this one in slope-intercept form. So again, we have a point, we have a slope. So we're going to use point slope first, which is y minus y1 equals m times x minus x1. And this is x1 and this is y1. And we'll fill in the blanks here. So that's going to be y minus 0 equals 10 times x minus 5. Right? Plugging the pieces in. And this one's actually very, very easy. We want it in slope-intercept form. So all we need to do is distribute the 10 through, because that's our slope. The 0 is gone, so that leaves you now with y equals 10x minus 50. And that is in slope-intercept form. Now, I want to look at two more of them where we're going to write these in standard form, but they're either going to have a 0 slope or they're going to have an undefined slope. So these we're going to write in standard form. And I'm going to give you a point for -3, let's say, and you got a slope of 0. So let's do this one first. Now, this one is very easy. Okay? Don't try to overcomplicate it. So we need to remember something about a 0 slope. 0 slope, that means we have a horizontal line. Right? Okay? 0 slope is a horizontal line. Let's go ahead and graph this one first so we can see how we can get our answer from the picture. So let's find our point for -3. That's over 4. And down 1, 2, 3. Okay, so there's our point for -3. Now, if it's a horizontal line, horizontal lines look like this. And if it's a horizontal line, what axis does it cross? Here's the y-axis. Here's the x-axis. Horizontal line looks like it crosses what? Crosses the y-axis. And if it crosses the y-axis, where does it cross the y-axis at? It's going to be down 1, 2, 3 units. So what would your answer for that one be in standard form? Y equals a what? -3. That's it. You can't write it in slope-intercept because you don't have the x there. So that's the standard form. What about an undefined slope? Well, if the 0 slope is horizontal, what do you think an undefined slope is going to be? Vertical. Okay? Instead of it being an x, it's going to be a y. So let's write this one again in standard form. I'm going to change the ordered pair again. And let's say I give you 8, -2, and a slope that is undefined. Well, undefined slope, that means it's going to be vertical. So undefined is going to mean vertical. Proceed exactly the same as we did the last one. An undefined slope. We first find our point, 8, -2. So that is forward 8 units. 4, 5, 6, 7, 8. And down 2. So right there it is at 8, -2. It's a vertical line in this case. So it looks like that. And what axis does it cross? Here's your x-axis and here's your y-axis. Crosses the x-axis. And that means it crosses at what? Where does it cross the x-axis at? 8. So what would your answer on that one simply be? X equals what? 8. Now, that was that first page. Now, if we look at the second page, and there's a fact, it kind of messed up a little bit when we copied it, but on the next one, which is here, on the back, we want to find the equation of a line when you're given 2 points. I didn't copy the greatest, but it works. Now we do have an extra step. So what's the extra step? Find the slope. Then we apply our point slope formula. Then we either write our answer in standard form or in slope intercept form. So now I'm going to give you 2 points, and we're going to write this one in standard form. How about the point 3, 2 and 4, -5. So now we need to look at this as having 2 points. Here's our flow chart. It's just like a recipe. That's what we're doing. Let's go into the steps here. We're going to find the equation of a line when you're given 2 points. So what's my first step? First step we do is we find our slope. I always like to write the formulas down at each step. So the first thing we'll do is we'll find the slope. And m equals y1 minus y2 over x1 minus your x2 here. So that's what we're going to be looking at. And label your ordered pairs x1, y1, x2, y2. Plug the values in. Watch out for double negatives, so be very careful with those. The y always goes first. A lot of students make the mistake of doing the x on top, but it's not. It's the y. So filling it in, those 2 go first. So it's 2 minus a -5 over 3 minus 4. Double negative here makes this positive. And now we've got 2 plus 5, that makes it a 7. And 3 minus 4, that's a -1. And so now my slope is a -7. We want to find this one in what's called standard form. So now we move on, and now we're going to use point slope. And that is y minus y1 equals m times x minus x1. We'll fill it in. So we're going to use that point. 3, 2. So that's our x1 and our y1. And then we found our slope to be a -7. So filling it in. We have y minus 2 equals a -7 times x minus 3. Be careful with that -7 with the negative, so make sure you distribute it through. Watch your signs there. Now we've got y minus 2 equals, distributing through, a -7x. Double negative makes it a positive 21. Right? Now we want this in standard form, and what does standard form look like? Okay. Here's standard form. So it needs to look like this. No fractions, no decimals. We don't have any of those. We need to move that 7x over. And we need to add the 2 over as well. So now we have, watch your signs here, moving that 7x over. We have a positive 7x. Okay. We have the y that's still staying there. So those are gone. 7x's cancel. And then you have 21 plus 2. That makes it a 23. Is this in standard form? Yes, it is. How do I know it's in standard form? X's and Y's are on the left-hand side. No fractions and no decimals. Okay? We need to now go to the last page. And this, I think, is the most complicated one. And that's why I want to make sure we do at least 2 of these. And this one is when we're going to find the equation of a line given a point and a line equation. And so what we need to do is we need to solve this equation for y. And then the directions will say either parallel or perpendicular. If it's parallel, we use the same slope. If it's perpendicular, we use the negative or the opposite reciprocal slope. Sometimes I say negative reciprocal, sometimes I say opposite reciprocal. That just means different signs. Then we go back to point slope, and then finally after that, we either write it in standard form or we write it in slope-intercept form. Okay. So we'll work through a couple of these. We need to make sure we at least get through 3 of these today, which we should have plenty of time to. And I'll do 1 parallel, 1 perpendicular, and then at least 1 special case. So let's write this one in standard form. And you're going to be given the point for negative, how about negative 4? And we want it to be parallel to this equation. How about 3x plus y equals 7? So you're going to have to be given a point and a slope. Now, what does it say to do? This is the last page in our flowchart. And this is the most complicated one. I think the flowcharts really help. So what does it say to do? Let's make sure we know we're on the right flowchart. The last page says, find the equation of a line when you give it a point and a line equation. Is that what we have? Yes. Okay? Because we have a point, all right, and we have a line equation. So what does it specifically say to do? Let's make sure we pay attention here, because these are the difficult ones. The others aren't nearly as difficult. This one I want to make sure we know what to do. So what do we need to do? Follow our directions. Solve the equation for y. Okay, so that's our first step. We take the equation that we have, and we need to solve this for y. So we've got 3x plus y equals 7. We'll move that 3x over. Now we've got y equals a minus 3x plus 7. And what is my slope? We need to find that slope. Okay, slope is that negative 3. Number in front of the x is going to be our slope here. Now, if it is parallel, what does it say? We need to make sure we're paying attention here. It's very, very important. Parallel says use the same slope. So what did we find our slope to be? We found our slope to be negative 3. So that means we're going to use m equals negative 3 because it's parallel. Okay. So we're going to use that negative 3 because it's parallel. Now what do? Right, we just solved it for y. We found our slope. Now we're going to use point slope. And that is y minus y1 equals m times x minus your x1. And now we go back and we've got this point. And what's our point? 4 minus 4. So this is x1, and this is y1. And we can fill it in with this and our slope here. So now we've got y, watch your signs, minus a minus 4 equals minus 3 times x minus 4. So watch out for double negatives. The double negatives at this 4 are going to make that positive, and then we're going to distribute the negative 3 through. That leaves you with y plus 4 equals a minus 3x. Double negative makes it a positive 12. Almost finished here. So we want this in standard form. So that means we need to move that 3x over and move that 4 over as well. So that leaves me now with 3x plus y. That's what we want. X and the y on the left-hand side. And what about the right-hand side? Well, 12 minus 4. 12 minus 4 makes it a 8. So there is your answer in standard form. And we use the same slope because we were looking at parallel. Next one, we're going to do probably 2 more, maybe 3 if we need to. The next one will be difficult. The others will be easier. We're going to do one now where we have to have a perpendicular slope. And this one, we're going to write in slope-intercept form. This one we're going to write in slope-intercept form. And again, I'm going to give you a point, and I'm going to give you a line equation. So in this case, you're going to be given a point. How about 2, negative 3, and we want it to be perpendicular to about 4x minus 2y equals 7. So this one, we're going to do exactly the same as the last one. So let's try to pay attention through this one. What do we need to do? Let's follow our flow chart. We're on the last page. Okay, we want to find the equation when you're given a point and a slope, point and a line equation. That's what we've got. What do we do? First things first. Take that line equation and solve it for y. So that's what we need to do. So we need to take this line right here and we need to solve it for y. So I'm going to move that 4x over. And that leaves you now with a minus 2y equals a minus 4x plus 7. I'm going to divide by that negative 2. And now we've got y equals negative and negative makes it a positive. 4 over 2 makes it a positive 2x there. And then we've got a minus 7 halves. Very important that we remember that. It's perpendicular. So this is going to be my slope. So my slope is 2. But we're not going to be using 2. Why not? Because we want the perpendicular slope. So that's the negative reciprocal. So since it's perpendicular, you're going to use the negative reciprocal slope. So that means we're going to be using m equals minus 1/2. We flipped it over. And we take the half, we flip it over, and we change the sign. It was a positive 2. Now we flip it over and change it to make it negative. So this is what we're going to be using. Once we've gotten to this step, now we proceed. And what does it tell us to do? Okay, it says if we're here, right, we're going to move on, and we're going to use the point slope formula. Which is y minus y1 equals m times x minus your x1. And we're going to be using this slope of a minus 1/2. And we're going to use that point to negative 3. So that is x1, and that is y1. Okay, let's fill it in and see what we now have. So filling this in, we get y minus, watch your double negatives here, minus 3 equals minus 1/2 times x minus 2. Double negative makes that positive. Distribute that negative 1/2 through. And now we get y plus 3. Distributing that half through, we get minus 1/2 x. Double negative makes it positive, and half of 2 is a 1. We are almost done. We want this one in slope-intercept form, so what do we now need to do? Move that 3 over, and that leaves you now with y equaling a minus 1/2 minus 2. And that is your answer in slope-intercept form. I want to do 2 more of these, but they're going to be a lot easier. And I'll go ahead now and pass out the sign-in sheet. But we need to do 2 more, and these are going to be really quick to go through. Okay, so let's do 2 more of these. It won't take more than about 5 minutes to do both of them. And then that will be it for today. So let's do 2 more of these. Now, these are the x and the y lines. And on these, we're going to find the equation in standard form. And you're going to be given a point in the line equation again. So let's say we have 5, 2, and we want it to be parallel to x equals 9. Okay, now, what does it mean when I say parallel? These are easy. I don't want anyone to make a mistake on these. These are very simple to work through. When I talk about parallel lines, what do we know? Parallel lines look like this or like this. They never, ever cross. So we are not going to have to do this one with any numbers, with any mathematics. We're going to draw a picture, and you're going to see how we get our answer. So when I say parallel to x, let's first draw that line and graph that line, x equals 9. What would it be if I graphed x equals 9? Here's your x-axis. 2, 3, 4, 5, 6, 7, 8, 9. Okay, x equals 9, that means it's a vertical line like that. Okay, because an x line is vertical, y lines are horizontal. When you have both variables, they're diagonal. So this is going to be a vertical line. Now, what's my point? Let's plot our point. 5, 2. So 5, 2 would be over 1, 2, 3, 4, 5, and up 2. 5, 2 is right here. Now, what kind of line would be parallel to a vertical line? Another vertical line, right? Because that's the only line that can't cross it. And this is your vertical line. Now, what does it go through? It goes through the x-axis. And where does it go through the x-axis at? It goes to the x-axis at 5. So this line would be x equals now what? 5. And that is it. X is parallel to x. Y is parallel to y. And x and y are perpendicular. so x is parallel to x, y is parallel to y, and x and y are perpendicular to each other. So let's do another one. This one will do perpendicular. So let's say you're given this point, a new point again, 8, negative 3, and we want it to be perpendicular to x equals 1. Well, what do we know about x and y? X and y are perpendicular to each other. So they form an x like this. They cross. So we could work this one out, but let's think about what it means when they're perpendicular. Okay? X and y are perpendicular. So that means this one is an x line, so we want then a y line. And we want, what's our y line here? What's the y component? Here's your x component. Here's your y component. Okay, y is negative 3. So we want now y equals what? Negative 3, and that's it. Let's do another one just to make sure that we have it all worked out here. These are the easy ones. So we'll do one more, and this will be our very last one. It's not much to it. So you're given 9, negative 4, and let's do a parallel one. Let's say it's parallel to y equals 18. I could graph this one out, but what do we know about y? Y is parallel to y. So what do we want now? Well, we want a y line. So we'll be wanting a y line. And what is the y component of this ordered pair? Here's your x component. Here's your y component. Well, we now want y equals a negative 4. Well, let's now go ahead and talk about our homework. So what's our homework? Well, our homework is going to be 2.3. You should be able to do them all. That's going to be your homework. If you've got 2.1 and 2.2 done, you can turn them in. If you want to turn them in next time, you can do that too. But you just don't want to fall too far behind. But if you haven't done so, you might want to look at 2.1 and 2.2. Okay. Anybody else have any questions? All right, well, I'll let you out a few minutes early. And then I will see you on Thursday. And try to work through 2.3 because I guarantee you'll have questions out of 2.3. 2.3 is the hardest section in this chapter. The rest is easy. I will see everyone then on Thursday.